Think back to the image we saw, the very close-up image we saw previously of a knife, and the description we saw that a knife can be made from steel where the spine of the knife is made of thicker material and then it tapers down to a very sharp blade. Then the knife smith can heat up that blade, cool it in water or oil, most likely oil, and that will harden the particles that the iron or that the steel is made of will harden into a crystalline structure, and the blade part, which cools faster, becomes hardened steel, and the thick part, which cools more slowly, doesn't get as hard. It stays as what we call mild steel. And that takes a lot of precision and a lot of training for people to do that correctly. But we saw the interface between the hardened steel and the mild steel. That was actually a combination of materials, even though it was all steel to begin with. Here we see a couple of other knives. Okay, the one on the left is a ceramic knife. The one on the right is an obsidian knife. Obsidian is a natural material. It's a mineral made from cooling lava, and it's been used by a lot of people. But before the development of steel, or really the ability, before people had the ability to really work metal, a lot of cultures would make blades out of obsidian. Well, what advantages and disadvantages do each of these materials have? You'll look at them and you'll answer the questions below. As an example of trade-offs, sewing thread should be strong, but it should generally be weaker than the fabric. If you get your shirt or your pants caught on something, then the thread will rip, but the fabric hopefully will not. It's a lot easier and less expensive to replace broken thread than torn fabric. You can actually probably do that on your own with a needle and thread. Think of a situation where a material has a property that is desirable to a certain level, but not beyond that. So think about something that is engineered to fail. It's designed to break in a certain way. And why? And think of a few ideas. Make a list in your notes of the trade-offs involved and describe how you would choose a material. An example might be a dog collar. Dog collars often have a part, like a plastic part on the collar, that breaks pretty easily. Now, if you own a dog and have a dog collar that breaks, that might have been frustrating that your collar was broken or that your dog's collar was broken, but that actually serves a purpose. The reason why that's made out of something that will break or disconnect is so that if the dog gets the collar caught on something, he or she is not going to choke, and it's a safety issue. The trade-off, of course, is that the collar might break at the wrong time. Maybe if you have a strong dog that pulls on the leash, maybe the dog can even break the collar. That would be terrible, because the pet could run off, and you would no longer have control of it. Materials should break as desired. In this case, we want the collar to break if the pet is in danger and needs to get out of its collar, but that's the only time. So material should break as desired, be flexible, and preferably be attractive.